If you're thinking about majoring in biomedical engineering, this video is for you. My name is Rahul, and I graduated with my BME degree back in 2022. And I've spent the last 7 years exploring just about every career path that BME has to offer. The thing is, biomedical engineering is an extremely broad field, and that's very exciting, but it can be kind of overwhelming to figure out which direction to pursue. And in this video, I will break down the main career paths in BME so that you can figure out which direction to go in. The most common path for BMEs is to go into industry, specifically the medical device industry. But even that is pretty broad. And there's several different roles in industry that BMEs can go in, and I'm going to break down each one because they're all very different. The first one is your R&D, research and development engineers. And from what I've seen, this is the dream job of most of your classmates. What you work on is product design, prototyping, and the innovation behind medical devices, and it sounds really cool. The downside, though, is that it's the most competitive job to go for. You're often going to be competing not just with your biomedical engineering classmates, but also with people from mechanical, electrical, and chemical engineering. And oftentimes, those other disciplines have a more rigorous engineering training in their fundamentals than you would as a biomedical engineer, simply because biomedical engineering is a much newer field. Now, that being said, it's still possible for biomedical engineers to work in this field. I mean, that it is the most sought after job from our major. And what I've noticed is the people who do get these jobs are the ones who are at the top of their class. They're the ones who have multiple internships, and they are the ones who often go to graduate school and have a more advanced degree to actually get those higher level R&D jobs. Now, I'm not saying this to discourage you from going for an R&D role. I'm just saying to be intentional about the kind of role that you're going for. The next type of industry role that you can get is a manufacturing or process engineering job. Now, this is actually where I see most BMEs end up straight after college. And there's absolutely nothing wrong with that. After my first year of college, I did an internship at Boston Scientific, which is a heart valve company, in a manufacturing engineering role. And your job essentially is to improve the production of medical devices. So this is improving the yield, reducing the scrap, and overall improving the efficiency of medical device production. Honestly, it's a great field to go into if you love problem solving and operations. So I can see why many people want to go in this field because it's a great entry point into the medical device industry. Oftentimes, what some people do is actually start off with a manufacturing engineering or process engineering job and then switch over to R&D later in their careers when they have a lot more experience. Now, that being said, there's also a third main type of industry role that you can go in, and those are your quality or regulatory affairs engineers. Now, honestly, it surprises me, but a lot of people don't actually know about this type of role until the middle of their BME journey when you discover it through your classes or internships. And I actually also did an internship in a quality engineering role at Baxter Healthcare. And pretty much what the job is to ensure that medical devices comply with FDA regulations, and you're going to deal with a lot of internal manufacturing issues, and you're kind of the internal policeman of the medical device production unit. It's it doesn't sound as sexy as the other two types of engineering roles, but it's actually very underrated because what I found is that the quality engineering jobs are always in demand because not a lot of people know about them and not a lot of people are applying to them. So, especially in our current job market, there's still always a demand for quality engineers. So, it could be a great um, career opportunity for you. There are also a few other more niche types of engineering roles, like solutions engineer at more software based companies and clinical engineer at a hospital setting. And what I found is that these roles are very job and company specific. Obviously, if this is something that aligns with what you want to do, go for it. But I would say that do your research and because there's so many different engineering roles, you should really do your research well in advance of your graduation so that you know what you're getting into. Now, while industry is the most common path to go in after your BME degree, it's not the only path. Many people, like me, want to further keep learning and advance their education. So, what you can do is go into graduate school. And the main types of graduate school for BMEs are getting your master's degree, a PhD degree, and your medical degree. Now, let's start by talking about the master's degree. Typically, this takes 1 to 2 years, and the goal of the master's degree is to deepen your foundational knowledge, deepen your technical skills, so that you can enter industry at a slightly higher level and a higher pay grade than you would straight out of undergrad. And that can be a great thing to do in just 1 to 2 years. The problem is, it's the downside of doing a master's is that it can be quite expensive. It costs typically uh, even higher tuition than undergrad. So it can be very difficult to do early in your career. So what a lot of people do is enter industry for a few years and then come back to school to do their masters. Oftentimes, if you work for a company for a long enough time, they will actually pay for you to do your master's degree, which can be a really nice option for you. Alternatively, if you're the type of person who loves to do research, then a PhD in BME might be the option for you. So, a PhD in BME opens up roles in academia where you can become a professor, where you can run your own lab and run your own research projects, or you can open up more advanced roles in industry, like the advanced R&D positions or industry scientist positions. And actually, what I've noticed over the last few years is that a lot of people are going down this PhD route specifically to go into the more advanced R&D roles because the job market has been so rough in the past few years. And of course, the academic option is still there with your PhD, although you'll probably get paid a little bit less as a professor than you would in those advanced R&D roles, but in exchange you'll get more freedom of what you get to work on. So it's a trade-off that you have to make, and I think as you do the PhD, you'll start to learn what you value more in your career, either the pay or the freedom. Now, there's also this common misconception about PhDs that when you get a PhD, you're making yourself overqualified for any of the jobs out there. But just like any other job, when you get a PhD, you will be overqualified for some jobs and you will be underqualified for some jobs. The challenge, though, is to find the job that matches the skills and experience that you develop during your PhD. And this is true for any job. So I wouldn't not do a PhD if that's your only reason not to do it. Another thing that BME students often do is become pre-med and decide to become a doctor. And at my school, UC Irvine, we actually have a separate major called BME Pre-Med, which contains all of the pre-medical requirements for medical school. And actually, I started off as a BME Pre-Med major because before I discovered research, I actually wanted to become a doctor. Now, I actually think BME is a great major for people who want to become doctors because, in addition to all of the biology and chemistry classes that everyone else is taking, you're also being trained as an engineer and you learn to look at problems a different way. And because you're so exposed to the unmet clinical needs, you bring a new perspective to the field of medicine than all of the thousands of other applicants who are just doing biology and chemistry. So, this can actually help you stand out in the med school application process. However, that being said, BME can be a very challenging major, especially compared to the more typical pre medical majors. So it's really important that if you're going to apply for medical school, you still have to prioritize getting very good grades and good test scores so that you can be a competitive applicant. Besides the traditional career paths of industry, grad school, and med school, there are also some more non-traditional career paths that a lot of BMEs end up pursuing. For example, if you're interested in the legal side of biotech, a lot of people become intellectual property attorneys or patent attorneys or legal consultants for biotech companies. So actually many BMEs end up going into law school so that they can actually achieve those roles. Another non-traditional path that people go in is to start your own company. As a biomedical engineer, you are literally trained to spot the clinical unmet needs, which is literally where all of the healthcare innovation and new companies formations happens, right? So many BMEs end up starting your own company, and this is something that I've attempted in the past as well, and I think it can be incredibly satisfying. So definitely keep that option open as well. Also, if you're interested in more broader policy and regulation level things, then you can also go into government. Many BMEs work at organizations like the FDA and the NIH, and they have a lot more broader impacts of public health policy, medical device regulations. Those are the types of things that you can work on as well. As you can see, biomedical engineering is such a broad and exciting field, and there's so many career options to choose from. That being said, there is no correct option. There's just the option that's right for you. If you'd like to see me go deeper into a specific one of these fields, drop a comment below, subscribe if you like the video, and I'll see you next time.